Hello everyone. Today we're going to be doing a review of chapter 5, so a lot of integration problems in this lesson. I'm going to be going over the worksheet. The answers are already written, but I'm going to just break it down and explain it in case you're having any trouble following the solutions, and also to give a little bit more detail and context about why I was doing the steps I was doing. So in this first question, they're saying if they give us a fact that we're not sure what to do with, then what is this? So our goal is to figure out what this integral is. If you look at here, you'll see that they tell us this part, but then what's this minus 2? So the key thing to remember in doing this problem is that the integral of some f of x plus g of x function can be broken down into the integral of each part separately. That is key to remember. We can't do that same thing with multiplication or division, but we can do it with addition and subtraction. And because of that, we can break it down. So the integral of this function minus the integral of this function. And that's what I've done here. The first part minus the second part. This part is given to us, so we just sub it in here. So that's what I've done there. And then the antiderivative of 2, is 2x, right? So we're evaluating between a and b. So we get 2b minus 2a. That's how I got this part. I just kind of skipped this step. And truth be told, the antiderivative of 2, I usually just think of it as, well, that is the area under the graph y equals 2 between, in this case, a and b. And so really that's just a rectangle, and we know the area of a rectangle is the width, b minus a, times the height, in this case is 2. So the area would be 2 times b minus a. So that's kind of algebraically and that's kind of graphically, and they're all saying the same thing. And so then you just simplify to get your answer in this one. So two key things were to split it up and then to know how to do the antiderivative of 2, which is super easy, but maybe in the context of this problem you got yourself confused. All right, number 2, what's key here is you see you want to go from the small number to the large numbers, usually are bounds of integration. So 1 to 6, but then this one is 6 to 4. So you want to flip it around so that the smaller number's on the bottom. So you have the integral from 4 to 6, and you just have to take the opposite of that. So really the key thing to remember there is that the integral from a to b of f of x dx is the same thing as the opposite of the integral from b to a of f of x dx. And so that's what I was applying there, and you just have to pick up on it and look for that. Side note, that might be on the test, so pay attention on your test if that's there. This is very common on the AP. So they're telling you something about 1 to 6, so I like to just put it on a number line. They're telling us from 1 to 6 the area under the curve is 15 halves, right? And then from 4 to 6 the area under the curve is negative 5. Okay, so this part right here from 4 to 6 is negative 5. And then they're asking you, well, what's this part from 1 to 4? Well, that would just be what plus a negative 5 is equal to 15 halves. So add 5 to both sides. 5 is equal to 10 halves, so that would be 25 halves, and that's how we get our answer to number 2. Number 3, we're doing a trapezoidal approximation for subintervals between 2 and 4. So break it down between 2 and 4, and you're doing 4 subintervals. So that would be 4 minus 2 over 4, which is 2/4 or 1/2. So that means our delta x, our width, is 1/2. So then you don't need to memorize any fancy formulas. I was kind of doing it the quick way here, but if you want to write it all out, you can say, well, the width is 1/2, and the width is 1/2 everywhere, right? It's 1/2, it's 1/2, it's 1/2, it's 1/2. So I am going to factor that out. And then the first trapezoid, this is trapezoid 1, right? I use those two. So f of 2 plus f of 2.5 all over 2. I am averaging those. And then the second trapezoid is going to be these two. And then the third trapezoid is going to be these two. And then the fourth trapezoid is going to be these two, right? That's why you can see that I counted the first one only once. I counted this twice, and then that last one just once, right? As you can see in this drawing, that was why. But if you don't want to break it down like that, you can just do all of the averages of each one. So first trapezoid, and then the second trapezoid, you're going to use f of 2.5 plus f of 3 over 2. plus, now you're going to do 3 and 3.5. You're just averaging them. And then the last one is 3.5 and 4. Okay, so again, you're just averaging them. Remember when we were doing left, we would have just done f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. In trapezoids, we have to just average them. That's it. So it's the same thing you were doing with left, right, and mid, but with trapezoids, we're just averaging both ends. Instead of just taking the left or just the right, we're averaging the left and the right. That's the key. So if I was looking at it this way, then you would see that you could take another 2 out everywhere there. So you have the 1/4, right? And then what is f of 2? That is 1 plus 2 squared is root 5. And then you would have had, 2.5 squared plus 1 is 7.25. And you would have had root 7.25 plus root 7.25. And that's how you would have ended up with the 2 root 7.25. Anyway, that's how you do that problem. Next one is going to be the same deal. So 0 to 6, trapezoidal approximation with 3 subintervals. So the delta x is 6 minus 0 over 3, which is 2. So that's why I have a width of 2 everywhere. Because that width is the same, I can factor the width out. So that is my delta x. And then this 1/2 is simply because, again, I just kind of did a shortcut, but I was thinking to myself width times, and then I'm averaging the 0 and the f of 2 point all over 2 plus f of 2 plus f of 4 all over 2 plus f of 4 plus f of 6, average of that. That's why it's all over 2. All right. And now in this one, because I'm multiplying everything by 2, that's why the 2 cancels out. And I just am left with f of 0 plus 2 times f of 2 plus 2 of the f of 4s plus just 1 of the f of 6. And then I would put those in and I would get D as my answer. In number 5, they're saying if a trapezoidal sum under approximates and a right Riemann sum over approximates, which of the following could be the graph of the function? Okay, let me think about my trapezoids in this magenta color, and I'm going to then think about my right Riemann sums in this turquoise color. So the trapezoid is, remember, you're averaging the left and the right. So you're averaging them, and you would kind of do that as your approximation. And so that's clearly an over approximation with the trapezoids. So I'm crossing this out because the trapezoid should under approximate. In this one, again, you're averaging the left and the right. So that's clearly, again, an over approximation, right? It's more than the area of the curve goes over. So I'm going to cross that one out. This one, that's clearly an under approximation. So this one's game. This one, that's clearly an under approximation also. So that's game. And this one is neither an under or an over approximation. It is exactly the same thing with the trapezoid. So it doesn't under approximate. So that one is also out. So we're left with just C and D as my possibilities. I'm going to go through all of them for the right Riemann sum, even though you don't really need to, just to talk it out with you guys. So for this one, I'm just going to do one right, and I'm just going to do it like that, right? Because I'm using the right to make my rectangle. So clearly in this one, this is an under approximation because it's less than what the curve was. So this was an under. With the right on this one, you can clearly see it's an over approximation. I go over what the area actually was, but that one was already crossed out, so that's why it's not the right answer. On this one here, that is clearly an over approximation, right? I'm going over the curve, and so that one looks like it is checking off both. Let's just check the others. So this one, if I'm using the right, that is clearly an under approximation. So that's why that's not the right answer. And then if I were to do this one, it would have been an over approximation, but I had already crossed it out. So that's how I do that one. This next problem gives us this table, and they're asking us the trapezoidal from 1 to 12. So something else that might be on your test is that it's not asking you to use all of the data. So this one is from 1 to 12. If I had just asked you the integral from 5 to 12, then you would have only wanted to use these 3 data points. So look out for that on your test, okay? The other thing to look out for is the width. We were taking out the delta x in this problem in this one because the width was the same for all of our rectangles. But in this one with data all the time on the AP, they give you ones where it's not equal width. And this is a prime example because this is 2 and this is 2. But this width right here is 4. And then this last width is actually just 3. So for the trapezoidal approximation for this one, you cannot use a formula. And there is no shortcut. You have to do each of it separately because you really need to be thinking of all the different widths here. So the trapezoidal with 4 is going to be width, which is 2, and then the height is the average of the 4 and the 10. And then the next width is again 2, and then you're averaging 10 and 14. And then the next one, the width is 4 now, and you're averaging 14 and 11. And then the last one, the width is 3, and then you're averaging 11 and 7. And that's how you get that answer. Now, I do want to do a little bit of extra practice since we're here. Let's go ahead and do left, let's do right, and let's also do mid. And I'm not going to write the number here because it might change since I have a limited amount of data. So with left, go to magenta, the left, I'm going to be using left, 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 left. First width is 2, and my first left is 4. My next width is 2, and the left, right? The left is 10. My next width is 4, but what's the left one? The left one is 14. And then my last width is 3, and what's the left one? The left one is 11. Now when I'm doing right, I'm going to be doing that one in turquoise. So my first width is still 2, but my right is 10. 2 times 10. My second width is still 2, but my right is 14. My next width is still 4, but my right is 11. My last width is still 3, but my right is 7. Let's go with purple for the midpoints. And how many midpoints? Well, I can't keep the widths the same because there's nothing in between. There is no data for 2, and I can't just make it up. So I've got to extend my rectangles with midpoints. I got to go from 1 to 5 and then from 5 to 12. It's the only way to do my midpoint. So I'm only going to have 2 with midpoints. That's the best I can do. So my first width is going to be 4, and my mid, so in between those two, is 10. 4 is my width, 10 is my height. The next from 5 to 12, that's a width of 7, and what's in between in the middle is 11. So that's how you do all of those. Number 7, they're telling us that the graph of F is shown up here. Find a trapezoidal approximation of the area under the curve between -2 and 8. So they want us to do trapezoids even though they're giving us a graph. In this one, we are using 5 subdivisions. They tell us our delta x is 2 actually. So really you're at -2, then you're at 0 because you're going by 2s, then you're at 2, then you're at 4, then you're at 6, and then you're at 8. And since you're doing trapezoids, you are averaging. So here I did the shortcut, but let me just write it all out for you in case you don't like to do it that way. If I was doing it the longer way, width, I'm going to factor the width out because it's the same everywhere. And then I'm going to average f of -2, which is -1, and f of 0 is 0. I'm going to average those. Plus, then I have a 0 and a 1, 2, 3. Okay, a 0 and a 3. Those are just my f of 0 and my f of 2 values. And then my next one's going to be 3 and 4, averaging those. And then my next one's going to be 4 and 3. And then my last one is going to be 3 and 2. And so you can see this is the same thing because I have the -1, I have 2 of the 0s, I have 2 of the 3s, I have 2 of the 4s, I have 2 of the 3s, and I have just 1 of those 2s. So either way you want to do it, you're going to get the same answer. Now let's get into some fun FTC. The derivative of the antiderivative brings us back to the function itself. This is the only bound with a variable. So when you put it in and then you chain it, this is what you get. So you have the 3 plus, put in the x squared, and then you're squaring it, x squared squared, taking the square root of that whole thing, and then you're chaining it, times 2x. And so that's my answer to that one. This one is also an FTC problem because they're giving us f and they're asking us to take the derivative. So the derivative of the antiderivative is our function itself. So this is our only bound with a variable in it. You're going to plug it in. So that is 1 over root 1 minus sine x squared times, and this is the derivative of sine x is cosine x. That's how I get that. Now, if you're having any problem simplifying, really I just had cosine x over the square root of cosine squared, and I said that because you have to remember that sine squared plus cosine squared is 1, and so 1 minus sine squared, which is what you have here, is cosine squared. So 1 minus sine squared is cosine squared. So we can replace that here. Now, I know that somebody's going to ask, is this going to be on the test, or do I need to simplify it like this on the test? Well, I'm not giving you multiple choice questions yet. So if this was on a test, you could just leave this as your final answer and you would be good to go. On the AP exam, you have multiple choice, so you have to simplify sometimes. That's life. Next question is again an FTC. They are telling you the derivative of the antiderivative at the point 4 they want us to evaluate. So let me just break this one down real quickly. So if f of x is that, then f prime of x is going to be, this is my only bound with a variable, so plug that in, cosine, root x squared is just x, okay, times, and then I need to chain that bound. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So now if I put in 4, I'm going to have cosine 4 times 1/2, and then 4 to the negative 1/2 is the same thing as put that on the bottom and take the root, right? And so I have 2 times 2 is 1/4 cosine 4, and that's my answer. This problem, oh, what do you know? Another FTC. They tell us f of x is the integral from 0 to root x of g of t dt. This is the graph of g up here. What is f prime of 4? So let's think of what f prime is first. So f of x is the integral from 0 to root x of g of t dt. So if I take its derivative, that is our only bound with a variable. So I'm going to plug that in, g of root x, and then chain it. So the derivative of root x is 1/2 x to the negative 1/2. This looks a lot like the last problem we just did. And they want us to find f prime of 4. So f prime of 4 is going to be g of root 4 times 1/2, and then I have 4 to the negative 1/2. So that's root 4 in the denominator. So 2 times 2 again is 1/4, g of root 4, which is g of 2. G of 2, I can look at the graph here. G of 2 is simply 2. 1/4 of 2 is 1/2. And so that's my answer. Now, this next question requires you to think a little bit backwards. We knew, okay, so let me start with this. We knew, so in this problem, they're telling you f prime is f. We've known that for months now, right? If you look at f of 6 minus f of 1, you might think that looks, and I'm going to go backwards because it's kind of backwards thinking, that kind of looks like the f of x function evaluated between 1 and 6, doesn't it? That is f of 6 minus f of 1. Usually we go from here to here, right? So I'm kind of thinking backwards right now. And so this is usually the antiderivative from 1 to 6 of something. And what function's antiderivative is big F? The antiderivative of little f of x is big F. So if you can kind of think backwards, you're going to get back to, well, big F of 6 minus big F of 1 is the area under the f of x curve between 1 and 6. And so that's what my goal is here. Now, if that wasn't tricky enough, they're also starting at 1. So it's so tempting to start at 0 because we always like to start at 0, but we need to start at 1 in this case. And we just want to do from 1 to 6. And so we're just counting up really these boxes under the curve. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And then in my case, I just knew that this was exactly a half. So I knew I had 10.5 and I had a little bit more. And so I knew that this had to be my answer. I didn't actually calculate exactly what this was at first. I just was like, okay, that's my answer. But if you had a little bit more time, you know that this is actually 1 because it is, just think of it as that 1/2 base times height. 1/2 of 1 times 2 is exactly 1. But when I was doing it quickly, I literally just was like, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5, and a little bit more. And so it had to be D. There was no other option that it could be. All right, number 13 has a couple of parts. Let's have some fun. So they're telling us G is the antiderivative from -2 to x. So it's starting at -2 in this guy. Find G as 0. So that means let x be 0. Just let x be 0, not this part. So the integral from -2 to 0 of f of t is the area under the curve from -2 to 0. And that's just 1/2 base, which is 2, times height, which is also 2. So that is 4 divided by 2 is 2. Now they're asking G prime of 0. So if you know this is G of x, then we know that G prime of x, the derivative of the antiderivative, we're going to get back to the function itself, and there's no chaining required because that's just an x there. So that's just going to be f of x. So G prime of 0 is f of 0. G prime of 0 is f of 0. And this is the graph of f. So f of 0 is just 2. That's how we get that. Finally, they're asking us g double prime of 0, so just take one more derivative. G double prime of x is, take one more derivative, f prime of x. F prime of 0 is a slope at the point 0. So what is the slope at the point 0? The slope here, we're going down 1, left 1, down 1, left 1. So that slope is going to be a positive 1. And so that is the slope at the point 0 of the f curve. For what values of x in the interval -2 to 9 is the graph g concave up? So g is concave up when g double prime is greater than 0. But this is a graph of f. And what is f? Remember, f is the same thing as g prime. So that's why I labeled it the same thing as g prime. G double prime is greater than 0 when g prime is increasing. Because remember, f increasing means that f prime is greater than 0. So that would mean f prime increasing means that f double prime is less than 0. So, we got to be able to go forwards and backwards. So anyway, where's g prime increasing? So where is f increasing? From -2 to 1, -2 to 1. And then again, it's increasing from 7 to 9, from 7 to 9. I guess my answer got cut off here, so we better go over this part. For what values of x in the open interval -2 to 9 is g increasing? So g is increasing when g prime is greater than 0. And so again, this is the graph of g prime. When is it above 0? From -2 to 4. And then it picks up again from 8 to 9. That's our answer to that part. Now in this one, it's an integral and it's two things multiplied by one another and we cannot unproduct rule. So we're thinking, oh, hopefully this is a u sub. So this is probably my baby. So my baby is going to be our u, x to the 3/2. So our du is 3/2 x to the 1/2 dx. But do you see a 3/2 x to the 1/2? No, you don't. But you do see x to the 1/2 dx, right? You do see this part. So let's multiply both sides by 2/3. 2/3 du is going to be equal to this root x dx. So to sub in for the root x dx, we can just sub in that 2/3 du. I kind of skipped a step. I factored it out, but this 2/3 du is what I'm subbing in for this root x dx, right? And then I have the integral of sine of u. Antiderivative of sine u is simply negative cosine of u. And then I had that 2/3 hanging out. And because it's an indefinite integral, do not forget the plus c. When you don't have bounds, don't forget the plus c because the derivative of constant is 0. So you don't know if there's that plus c there. All right, this one, they give us the substitution. So they're telling us that this is our u. And I'm just going to resolve this problem just to work the whole thing out. So if u is 1 plus root x, and I'm going to write that as x to the 1/2, then du is 1/2 x to the -1/2 dx. I could also write that as 1 over 2 root x dx. Now, if I look at my problem, integral, let's just split it up. I have the 1 plus root x to the 3/2, and then I have this 1 over root x. So I'm going to just split it up into two parts multiplied to help me see things a little bit better. So now I see, oh, I don't want a 1 over 2 root x. I just want a 1 over root x. So I could multiply both sides by 2. So then I would have 2 du is what I can sub in for 1 over root x dx. So I'm going to sub that in. 2 du is going to replace this, and then this is u to the 3/2. So then at this point you just can take the 2 out, 2 integral u to the 3/2 du, and that's the answer that I was looking for. So I might give you a problem like this on your test, and I would just ask you if the substitution is made, then rewrite it, okay? And you would just leave your answer like this as your final answer. Just rewrite it with the substitution as opposed to an evaluate type question. This next one is the same deal. U is secant x. So you do need to know if U is secant x. So if U is secant x, or secant theta in this case, then du is secant theta tangent theta, if you've memorized that formula. If you ever forget, you can always prove it to yourself. And when I was doing this problem, I just thought that I would show you what you should do in case you forget any of the formulas. So, u is secant x, and so secant can be written as 1 over cosine, and 1 over cosine could be rewritten as cosine to the -1. And so du would be negative cosine theta to the -2 power, and then you need to chain it so the derivative of the baby is negative sine theta, and then you pretty much have a sine over a cosine squared, and the negative times the negative is the positive, and a sine over a cosine squared. Well, a sine over a cosine is a tangent, and then you have one more of the cosines in the denominator, and so your answer would be tangent, and then this is just secant, right? Now you might be wondering what I did there. Let me get there in a second. But this right here is totally extra work that you don't need to do if you memorize the formulas that you need to memorize for the AP. On the test, I'll be telling you exactly what formulas you need to know, so you would not see the secant formula if it's not on the topics list. However, I want you to have a backup plan in case you need to prove some of these things to yourself. All right, so let's pretend, instead of doing all that work, let's pretend that we actually remembered that, okay? So U is secant and our du is secant tangent. Oops, I forgot my d theta. All right, so how do I do this problem? There's a couple ways to think about it, but I'm going to choose to break it down like this right now. The integral from 0 to pi over 4, I'm going to split it up and I'm going to put the u stuff first. So I'm going to do 1 over root secant theta times tangent theta d theta. Now remember, when I said I go to use, I go all into use. I cannot mix and match u's and thetas in this case. So our bounds are going to be, instead of 0, secant of 0, remember secant is 1 over cosine, and the cosine of 0 is 1, so that's going to be 1. And then the secant of pi over 4 is right here, and the cosine would be root 2 over 2, and 1 over root 2 over 2 is 2 over root 2, and 2 over root 2 is root 2. Okay, if you're getting confused on the bounds, don't worry too much about that right now, okay? I don't want you to concentrate on that part of this problem right now. I don't want to let the trig bog you down. Use your calculator or something for now, okay? Now I have 1 over root u, that part's easy. But now what's tangent theta d theta? Well, look here. Let's break this down. We want to sub in for the tangent theta d theta part, right? So we know that tangent theta d theta is 1 over secant theta du, but I said I cannot mix and match thetas and u's. But what is secant theta? Secant theta is u. So isn't that just 1 over u? So 1 over u du is what I'm going to sub in for this tangent theta d theta, okay? We went all into u's at this point. And so now that's how we get that answer. Final problem. U is ln x. So I'm going to rewrite this down here, and I'm going to just split it up as a multiplication like I did in the last problem with the u stuff in front. So I have 1 minus ln x squared. I can't break that apart, right? Times 1 over x dx, because I just kind of pulled that out as a multiplication instead of looking like a division problem. So now I'm going to go to use, but I need to first change the bounds. So if my x bound is e, then ln e is 1. If my x is e squared, then ln e squared is 2. Then I have 1 minus u squared times what? Well, if my u was ln x, then my du is 1 over x dx. And this is pretty simple, because I'm just going to sub in the du. And that's it. That last one was a piece of cake. Real easy. Real nice. I think I put on the topics list that you might try solving this, and then I did give a solution there. So you might want to do that as you're studying for your test. But that's about it for this lesson. I hope this helped. Bye.